pretty good. I like the pizza points. The pizza points.
Better than it all that.
Dude, there's a choice.
So do those.
Is this in chapter 2?
Oh yeah. What's up?
Can I ask you something?
Yeah, sure.
Are we going to be putting values like A, B, and C in the equations?
No, this is part A, part B, part C question. Yeah, you're okay. So the question's there. That's part of the question. But let me help you out a little bit. Let's make sure everybody's on the right track. What do you do for part A? Plug in 3 in place of x there. You get 9 minus 9 plus 5. All right. That was nice. Another way to look at this. These two mean the same thing. So this means divide the functions and evaluate them at -2. Well, you can go ahead and evaluate them at -2 first, and then divide them. this one. F of negative 2, you plug a negative 2 in. You have 4 plus 12. This is negative, plus 6. So that's 10 plus 5, 15. This is negative, so the middle term becomes positive. It's squared here, so that's also positive. G of negative 2 is a fraction. Negative 4 over negative 3, so 4/3. And then, of course, how do you do that? Yeah, multiply by the reciprocal, so you get 45 over 4. So this equals 15 divided by 4/3, which is 15 times 3/4, which will be. So it's really just break the problem down into its two parts. You do that, and then you divide them. Yes, sir.
From where you get that?
So G of negative 2. Twice negative 2 is negative 4. Yeah.
I mean that 3.
The 3?
Yeah.
So G of negative 2, you get negative 4 on the top, and on the bottom you get negative 2 minus 1 is negative 3. The negatives cancel. Cool. How do you do this guy? Yeah, wherever x is, you put this. The answer is not 2w over w minus 1 plus h. Right? It's this goes in place of wherever the x is, so it's twice w plus h over w plus h minus 1. Oh yeah. That beautiful thing there. Yeah. No, there's nothing that can cancel. The only thing that could have a chance to cancel here would be 2. Because it's in both of these. But the bottom doesn't have any 2, so.
Can you repeat that again, please, sir?
So, the idea with functions is it gives you, and people always have trouble with this, but it gives you a template. I like it. It gives you a format for, let me look at the G again. What's going to happen? So the X is really just a placeholder. It says whatever I put in this, it has to be doubled and then divided by 1 less than whatever that was. And that's what's got to happen to whatever I put in there. So if I put an A in there, it's got to be doubled and divided by 1 less than it. If I put a Jeff in there, it's got to be doubled, divided by 1 less than him. If I put let's see, if I put in there a squared minus w plus the square root of 7, you can do it, Jeff. Then I've got to put twice all that crap divided by the crap minus 1. Okay, so it's format or template, I like that. And you're just filling in. The X marks the spot where you put the stuff that's in here. So this twice something divided by 1 less than it is the rule. That's what the G does to whatever the hell you give it. So whatever the hell you give it, do that to it. It's that simple. Okay. So this should be hopefully relatively simple stuff. So this could be like, give me more of this. Should be what your thought process is. All right. So what is a function? Kind of a broad question. Okay. I know. I always wait for somebody to do that. You didn't say I couldn't just read out. You're right. So, what it really is, the way I try to teach it when I teach it to my Math 90, Math 110 students is that a function is something that could model
a real physical world thing. So if I throw a ball in the air and I say, where's that ball 2 seconds later? You're not going to tell me it's 10 feet up and it's also 3 feet down. Now, there's only one freaking ball that you threw. It can't be in two places at once. So some of you guys might realize how that relates to some kind of a test you apply to see if something's a function visually, right? But a function, anybody ever watch or know of the show or in the movies, like Highlander? There can only be one. I love it. So whenever I see this definition, that's exactly what I think of, and it makes it a little bit cooler than it really is. But so what is a function? For every input x, there can be only one output. And we're now at the point where we realize x and y are not always the variables we use. Sometimes the input might be time, and the output might be volume. So you're making your Jiffy Pop on the stove top, and you're not answering the phone because you remember what happened. So what's your name? And scream. You're making your Jiffy Pop, and over time the volume is increasing and increasing. You with me? So you have a volume as a function of time. So you can have, for example, you can have volume as a function of time. So V of t equals some function of time. 2t plus 1 out there. You guys semi with me? Not at all. Okay. This is just a way to read this off. So right here, this is g as a function of x. So the quicker way to say that is g of x, right? So I could have income as a function of time worked, or income as a function of age, or I could have height as a function of age. You with me? So function is really something that takes one variable and relates it to the changes in another variable, roughly. The more detailed way to say it is like this. Every input, so there's one variable. There can only be one output, that other variable. So it describes some relationship between those two things. How does one affect the other one? Okay. Now, if I said this real quick, right? This takes the place, what does f of x really take the place of? Y. So this says y is a function of x, but how does it really relate? When x changes, what's y? Does y care? No, so a constant function is an example where x can do whatever the hell it wants to, and y is like, I don't care. It's 2. So if I said the height of the book from the floor as I jump, all right, still 2 feet up. All right, let me jump higher. It's still freaking 2 feet up. So the two obviously don't have any connection. All right. So let me give you something a little more detailed here. So if I had just give you kind of an example. This could be something like I have some kind of a trough, and it's catching rain that's falling. And the volume of the trough as the height of the rain goes up. You with me? As more and more rain falls, the height's going to go up, and the volume is obviously going to change with that. Not directly. This could be one way that volume changes. You semi with me? More than likely, it'll be a cube there. So before anybody yells at me, I'll do that. So you would say that this is volume as a function of height. So just to put it a little more directly, I'd say V equals 3/4 h cubed. Now, if I said I want you to rewrite that as height as a function of volume, number one, do you know what the hell that means? And number two, can you do it? So I want you to write height as a function of volume. Not yelling. Now, on one level, I'm hoping you guys realize how simple this is. Volume as a function of height, that means stuff is happening to the height, and the volume is just sitting back waiting, right? So I want you, what's another way to say this in a little bit better, more understandable English? Just get the h. Get the h
by itself.
Isolate the H.
So really what this is saying is, get the H by itself. So what I'm trying to show you is this is kind of building on stuff we already know. You've already been asked to do that problem way back to Math 90, solve for the indicated variable. But now you're seeing how it could relate to a physical situation. As the height of the rainwater goes up, the volume increases. Or you can look at it as the volume increases, the height must go up, because more of it's got to fit somewhere, right? So what do you get, of course, when you solve for H? Cube root of?
Cube root of B, about 4 over 3B.
Like, so that would be height as a function of volume. Okay, not a big deal. The one that says as a function of stuff, that's where things have to happen to it. So if I say volume as a function of height, height must have some stuff happening to it. Height is a function of volume. Volume is the one that's getting attacked. Okay. So the first thing we realize is if I now have this idea of a function, and this is not entirely exactly true, but what I try to get my students to understand is, for example, if I ask you what size shoe are you wearing on your left foot, and you give me 2 answers, I am worried about you. Are you wearing, I mean, it's entirely possible you have 2 shoes somehow stuffed on your foot, but more than likely not. So this idea of for every this, there can be only one this, that physical impossibility of having, you know, more than one ball in there after you've thrown one ball up, and all of a sudden, poof, there's 2. You know, or firing well, whenever I say this, shoot a missile up, you can say, somebody shot another one and broke it into me. Okay, all right, whatever, fine. Throw a frisbee. You can't say at time 5 seconds later, where is it? You can't give me 2 answers. That's freaking me out. Right? This physical impossibility, that kind of relates to this. For every one of these, there can be only one of these. Okay. So how does that relate to a graph? In order to graph something that would not be a function, what must happen? So there must be somewhere, okay, everything's great, oh, shit. Because this would be the situation where here I am walking on a mountain, and this is my time, and suddenly at this time, I'm in 3 different places. That would be useful, but not possible as far as I've tried. It's not possible. So that leads to the vertical line test. So the vertical line test really is just a visualization of exactly this definition. For every x, there's an x. There can be only one y. Well, if you draw a vertical line, it goes through more than once. Those are 2 y's corresponding to the same x that you drew from. So that's the visual representation of that definition. Cool. There's a more important idea coming at the end of chapter 2. This idea directly, whether something's a function or not, has some importance, but with overall math doesn't really care too much if you're a function or not. But for example, I can only graph functions in my graphing calculator. I can't graph something that's not a function in my graphing calculator without doing more than one input line. I can't. You'll see why later. What does it mean in terms of equations? How can I look at an equation and just know it's not a function? Visually, it's easy as hell. All I got to do is look, does it come back on itself somewhere, and then it's easy. How about with an equation?
Same equation, multiple answers.
So if it starts off like this, why is that definitely a function?
1x and what goes to 1.
I like it. For any input I put in there, it's only got one output. Right? For any number I put in, there's no way in hell this gives it, if I put a 2 in there, where would the other answer come from? It's got to be 4 times 2 minus 1. There's one answer for it. Cool? Okay. And this doesn't even matter here. For every x I put in, there's only one y that comes out. But what if I put a negative 1 in? What do I get? If I put a negative 1 in, I get 1. If I put a 1 in, I get 1. Well, who cares? All this says is that for any x you put in, there can only be one y. I don't care if two things have the same output. -1, does it go to more than one thing? No. 1, does it go to more than one thing? No. So it's a function. Right. Each x can only go to one y. So what about something like this here? It's a circle, which visually would be quick. But let's say I tell you you cannot use any graphs. This was easy because it's solved for y. And I have one thing that can come out on the side. So what happens if I try to solve this for y? You can do it. So minus x squared. And then when you take a square root, what has to happen? Plus or minus. So there's your, for any given x, there's going to be possibly two outputs. That's exactly the opposite of the definition. Not the opposite. It just doesn't follow this. So if I put in there 5, let's say real. Let's put in there 2. 9 minus 4 is 5. The output for 2 would be plus or minus root 5. It's got two outputs, no good. So if this is my rocket has cut in half. I'm sorry to tell you. It's probably not going to be very effective. Too bad for you. Are you guys kind of with me here? Okay. And the only, I can't remember now. I got to look real quick. I think if you do this, it always depends on the book. No, they don't. Good. All right. I'm tired of this. Sweet. I like it. So that's not too bad. That's the idea, the pure definition, the visual representation, and then what does it look like with math equations? How can you tell from looking at a math equation if it is or not? Now, let's get a little bit funkier here. So here's where people start to have some trouble. How many of you guys have ever heard of a piecewise function? Good, a few of you guys. This actually kind of sounds like what it's a function that's defined in pieces. So I could have a piecewise function that looks like this.
They do have the equation functions in 2 ways.
So again, sorry.
They have these kinds, like if you can tell if it's y is a function of x at 2.2.
Oh, yeah. Yeah. Thank you. So in real life, this is actually getting closer to real life. In real life, my car is sitting there. So its function would be very kind of, its position function, 0. Until I get in it and turn it on, and all of a sudden it has to start following a different equation. So at a certain time, it suddenly starts going somewhere. So it can't follow the same 0 equation. So here, something is like somebody's 7 foot up, and then they start moving. They take off, and they got the little jetpack, right? James Bond back in the 60s, he got those jetpacks that we should all have by now. And he starts going off the cliff. Okay. How's that? Is that all right? Or you could have a rocket, and you feed it some instructions, and it changes its trajectory. So you have one function up until the time you change it, and then it's got to be a new function now, describing how it's moving now. So piecewise functions are very true to life. This is how things normally happen. Things don't stay in that same place. They normally get acted on somehow. But how the hell would you draw this? How would you graph this thing? What seems to be a very important point? 1, because that's where things change. But here is one way you can do this, if you have any trouble with this. This one's almost too simple for this, but let's say this. Let's say. All right, make a little table. Some of you should probably not have to do this, but this might be good to get into it if piecewise functions look freaky. X less than 1. Now look what I'm going to do very first thing. I'm going to do this. I'm going to put a 1 in. Sort of. I still have to know where it wants to be at 1. So I can put what at 1? If it's not allowed to exist at 1, what do I have to put at 1? An open circle. Kind of with me? So if I said graph x less than 1, wouldn't you put an open circle on 1 and then shade down? What's that open circle really mean? You get crazy close to this, but you don't get here. Right? So I still have to do it two-dimensionally. X itself can't be 1 for an input, but I still have to see where does it look like it would want to go if x could be 1. So if I plug a 1 in here, of course, it doesn't care where the hell x is. It's always 7. 0 at 7, negative 1 at 7. Blah, 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 blah. So at 7, that's not smart, Jeff. Better scale. 2, 4, 6, 8, 10. All right, so it's 7 all the way up to 1. So right at 1, I've got to put an open circle there. And then it's 7 forever before that. You guys cool so far? Okay. And then right at 1, what takes over?
2x plus 3.
Yeah, this guy. So again, now I make the table starting at 1. Now I don't have to put a little parenthesis around him because I'm allowed to be at 1. So I'm going to put a closed circle there. So when I plug a 1 in here, I get 5. And 2, 3, it's going to be a straight line after that. So 2, I get 7. 3, I get 9. So at 1, this wants to be at 5. At 2, it's at 7. At 3, it's at 9. And so forth, right. Now this would be really difficult to claim represents a physical situation. Because I don't care how fast you move, you can't be here and then appear there unless you're on Star Trek or something. Right? They haven't fully perfected transportation yet, but they're working on it. So sometimes that second closed circle will fill in that open circle beforehand, but it won't always. Right? So you always have to investigate that transition point to see where's the open circle and does the other one come in and fill it in or not? Is it offset? So this really isn't that difficult. People, for some reason, they'll keep drawing that line, and they'll say that's not even a function anymore. It doesn't pass a vertical line test. You with me? So it's got to be a hard line. This is true only up till here, and then this takes over. And I can make this other one a parabola. I can make this one a radical, whatever. They can be composed of whatever functions I want to make them.
So it's the same function, right? It's the same length. Like those two are the same thing, right? Because that one takes over for the other one.
Yeah, this, they're not the same. I'm not sure how you mean.
I don't really know.
It's all right. This is not the best situation to explain because it can't be a physical situation. I can't say, well, he was sitting in the chair and suddenly, poof, he was over there. You know, I can't, because that's what that's trying to say there, right? But at this time, this took over for this. Yeah, that's another way to look at it. Okay, cool. I like it. Okay. Let's see. So, you guys try this one here. right, so let me try to catch up here. So this is allowed to exist up to negative 2 inputs. So if I put a negative 2 in, that'll be 1 minus 4. Negative 3. 1 minus 9. 1 minus 16. Okay. And so forth. That's plain. On the other side, it's not allowed to be at negative 2, but I still have to see where to put the open circle. So at negative 2, where would this be? 2. I like it, because negative 2 plus 6 is 4, root 4 is 2. And then I'm going to be smart, and the next thing I could actually do is if I get a 9 inside, so I'm going to put a 3. You don't have to do all the other ones, because you're trying to graph it. I can't graph 5.7823. So if I plug a 3 in, 3 plus 6 is 9, square root of 9 is 3. And that should be enough to graph this bad boy. Let's see. Scale such as so negative 2 is at negative 3. Negative 3 is at negative 8. Negative 4 is at negative 15. And that's parabolic, so it's going to go right? Down parabola, lesser known yoga position. And then for the other part, at negative 2, it would want to be at 2, but it can't be there, Jeff. And then at 3, it would be at 3, and it looks like a radical, so it would be sort of like that. And it keeps going, obviously. Yeah.
It's easy to make the graph, but what is the first step before that? Like, how do we get those plots?
You do a table of values, but you are very careful about the values you use.
You're saying like x is greater than minus 2, so we're gonna be going minus 2, minus 3. That's understandable too. But again, how are we getting those y plots?
The y points.
Yeah, y plots.
So if I'm plugging in stuff that are less than or less than or equal to negative 2, which one of these is in control? Which one of these works for things like this, for inputs? Which one? This one does. This has to find. So g of x is this if my inputs are here. All right, so that's how I made that. When you plug a negative 2 in here, 1 minus 4 is negative 3. So when my inputs are bigger than negative 2, I use this guy. That's all. That's why I make 2 separate table values.
Okay, how do you know like which equation will get the bigger dimension? Yeah.
So if I wanted this, which one would I use?
The x plus 6. Oh, this one, x1 minus x squared.
All right, good. There you go. You answer your own question. So just think backwards. If I want to graph this part, I better use inputs that are less or equal to negative 2. If I want to graph this part, I better use inputs that are bigger than negative 2. So that's pretty much what I did. Yeah. Part of this, of course, is knowing what these look like. You should know what cubes look like, what square roots look like, what absolute values look like. What do absolute values look like if you graph them?
The fat brackets?
True, but what do they look like when you graph them? V. Because it's not, the only thing that's curved would be powers other than 1. Absolute value of x, the x is to a first power. It should still be linear, it just is not allowed to be negative. So that's why it makes a hard V. Squared would be a soft U, right? So it truly is curved because it's got a power that's not 1. So you have to kind of know your basic look of your functions to be able to piece these together. Okay. Trying to build in time for a little tour around the campus too. So I have one more idea to go over, and then we're going to head out on our tour around the campus. It will take less than 8 minutes, so don't freak out. The one last idea I want to talk about is
So there's two kind of ways to look at this domain and range issue. I gave you a plot. It was like this here. This is our turn. So domain relates to, what does that word relate to? And, yeah, in general, the input, which normally is the x, and range, of course, is the outputs, the y's. So domain for this guy would start where? What's the lowest x value that actually has an output? If you have any trouble with this, obviously, so like have a little dude walking on the x-axis. What's the first time the little dude sees the graph? It is at -2. And he sees it all the way through until he gets up to 2. So the domain would be -2 to 2. Why am I allowed to use interval notation here? Yeah, it's all the way through, right? If there were some open circles in here, I could not use, I'd have to do little parts. You kind of with me? But since it's continuously throughout, I can use interval notation. And the range is the same idea, just the other axis. So that would be, what's the lowest y? -2, and what's the highest output? 3. All right, so that's one way that that question can be posed. Here's the other way. Now you don't want to graph these and then, no, you don't want to. You should be able to see directly. So domain is all of the inputs that actually have outputs. So in another way to say it is all the inputs I'm allowed to use. So when they ask you a domain question for a function they give you, for an actual expression, you say to yourself, what is it about this expression that would make it freak out? So in general, what freaks fractions out?
0 on the bottom.
Yeah, 0 on the bottom. So you say x squared minus 8x minus 20 cannot be 0. And you solve. So if you can say the restriction in English, just change that into math and solve. The bottom, this thing, can't be 0. Now how do you solve that? Factor rule. X minus 10. It's bigger one negative because it's got to be -8. So x cannot be 10 or -2.
Bigger one or smaller?
Bigger one's negative because this guy's negative, right? Yeah, but 2 and a 10? Yeah. Don't give me. What? Yeah.
What's up with the 3x?
Oh, why does the 3x not matter? Because the top can be whatever the hell it wants to be. Right? Even if there was something that would cancel out with the bottom, that doesn't matter. The bottom cannot be 0, period. Yeah.
Is it possible on the bottom is 0? Isn't there an incorrect on the bottom?
Yeah, yeah. And real quick, since you're asking. Why is 6 divided by 2 3? Because 2 times 3 is? Okay. What is 6 divided by 0 would have to be the number that's defined to be the thing that when you multiply by 0, you get 6. Is there a number defined to do that? That's why we call this defined. Some of you guys might know it by saying infinite. And that's more related to slope. Right? If you only rise and you don't run, you are infinitely going up. Right? So you normally call it undefined. Some of you might have called it infinite in the past. What about this guy? what's the restriction in English on a fourth root? What cannot happen? And this domain, whenever I say domain, it's kind of implied we're talking about real numbers. Beautiful. The inside can't be negative. So a mathematical way to say that is the inside has to be 0 or positive. So it must be bigger than or equal to 0. So if you can say it in English, translate that into math and solve. That's how you can always do those domain questions. So you solve this thing and you get that eventually. I think, pretty sure that's enough for today. So, do this for me. Try not to run away. Let's go on this little tour. I want to show you where my office is. We're going to run by the 2 tutoring centers that are on campus that are free. Show you where those are. So if you would, go out the door and go this way, but wait for me. We're going to go in the direction of the text ball, but wait until I catch up to you.